All right, let's do some 2.6 exercises here. Quick reminder for how to approach these is do the exercises yourself first, or at least try until you are stuck. And when you get stuck, watch just enough to get unstuck, then pause the video and keep going on your own. And if you are able to finish, check the answers with this video. And let's get going. So, first of all, with exercise 1, if you want to solve the system, you could either use elimination or substitution. I think it's maybe slightly easier with substitution, but I'm not sure. So, if you take this y, I'm going to solve for that y here by subtracting 3x from both sides. That gives you y equals 10 minus 3x. That expression can be substituted in for y here. So that'll give you x plus 2 times 10 minus 3x equals 15, which is a nice equation with just x in it. So we're going to distribute the 2 into that whole y thing here. And that gives you x plus 20, 2 times 10, minus 2 times 3, which is 6x. And let's see, I'm going to subtract this 20 from both sides. And x minus 6x is negative 5x. And over here we have 15 minus 20, which is negative 5. Divide both sides by negative 5, and you get x equals 1. And once you know that x equals 1, you can substitute that in over here. And that's going to give you y equals 10 minus 3 times 1, which is 10 minus 3, which gives you y equals 7. So the solution should be x equals 1, y equals 7. And if you want to check that, 3 times 1 plus 7, that is 10, yep. And then 1 plus 2 times 7 is 1 plus 14. That does give you 15. So that works. All right, B is pretty tricky here. If this one was not challenging, then congratulations, because it's probably challenging for most people. I want to do this one with elimination. I'm going to make the x coordinates be opposite each other. I'm going to multiply both sides of this one by 7. And both sides of this one by negative 9. And the idea is that 7 times 9 and negative 9 times 7, those are opposites. It's 63 and negative 63. So that will turn this into 63x plus 70y equals 147 for the first one. And the second one is going to be negative 63x minus 99y equals 26 times negative 9 is 180 plus 54 is negative 234, I think. Let me check this with a calculator just to be sure. Yeah, negative 234. Let me just check the 21 times 7 really quick. Got that one right. And yeah, I think the rest are good. Okay, so doing that trick there sets it up so we have a 63x and a negative 63x. So when you add these together, you just get 0x. Those basically cancel each other out. And the 70y minus 99 gives you negative 29y equals 147 minus 234 is negative 87. And then if you divide both sides by negative 29, you'll get 3. So that just gives you y equals 3. So we got some big numbers along the way, but it worked out to a nice small number for y. And then you can take that y and plug that in for y in one of these equations. It doesn't really matter which. I'll take this first one here. That'll give you 9x plus 10 times 3 equals 27. So in other words, 9x plus 30 equals 27. Wait, 21, excuse me. That's a... All right, and then if you subtract 30 from both sides, you'll get 9x equals negative 9. Divide both sides by 9. You should get x equals negative 1. So that should be the solution, negative 1, 3. And it's never a bad idea to plug these in for the x and y to check. So I can do this in my head pretty quick because I do this all the time, but you might need to write it out. So it's going to be negative 9 plus 30 is 21. That works. Negative 7 plus 33 is 26. That works. So that's your solution there. All right, going on to exercise 2. One rental company charges $20 plus 10 cents per mile. I guess these are rental cars that we're talking about, or something else that you use for miles. I don't know. Maybe rental forklifts or something. That would probably be more expensive. I don't know. Anyways, the other company charges $30 for 0 miles plus 5 cents per mile. At what distance is the second company cheaper than the first? Okay, so let's see. We want to know what the distance is. This is the goal here. So it's always a good idea to make up a variable. Let's call it x, or maybe d for distance. That makes the cost, let's call the cost c, equal. Because when they're equal, that's going to be the point at which the second one is cheaper. All right, so let's make up equations for these. Let's say that the first rental company charges $20, so the cost is going to start at $20 plus the cost per mile. So that's going to be $0.1, 10 cents, times the number of miles that you go. So you take the number of miles that you go, d, multiply that by 10 cents, and add that to the $20 base fee. Now the other one charges $30 plus 5 cents per mile. And if we want to know where do these intersect, so what is the value of d that makes these two c's the same? I think it's really good to be able to do this with graphing. You could also do, actually this is a good one to do with substitution. So I'm just going to do it with substitution really quick. What I'm going to do is I'm going to take this c here, and I'm going to replace it with this other equation for c, because it's already solved for c. So if you just substitute this in there, that's going to look like 30 plus 0.05d equals 20 plus 0.10d. And we want to get d on one side or the other. I'm going to subtract 20 from both sides. That'll give you 10 plus 0.05d equals 0.10d. We can subtract 0.05d from both sides. And that will give you 10 equals 0.05d. Divide both sides by 0.05 to cancel that out. And this is going to be 200 equals d. So that is the cost that makes that's the number of miles that makes the costs equal. If we want to know at what distance is the second company cheaper than the first, well, let's see. Let's pretend we're going to graph these. We can get a kind of sloppy graph here just to picture what's going on. The first one starts at $20 and then goes up by 10 cents per mile. So that's going to be going up a little bit steeper, but starting a little bit lower. The slope is 0.8 is 10 cents per 1 mile of increase. The other one starts a little bit higher, but then goes up not quite as steep. So at this point, we just found out the value of D that makes these two costs equal is 200. The question is, when is the second one going to be cheaper? Well, it's after this point. Over here at these values of D are what make the second one cheaper, because the costs are lower. The C coordinates are lower here. So to answer the question, what distances make the second company cheaper, it would be distances over 200 miles make the second cheaper. All right, let's look at exercise 3. We've got a farmer who has some chickens and some pigs, and his animals together have a total of 95 heads and 310 legs. How many chickens and how many pigs does the farmer have? So it's always a good idea to set up a variable with any kind of word problem for what it's asking for. Let's say that C is the number of chickens, and then P is the number of pigs. Once you're clear about what your variables stand for, it makes setting up the equations make a lot more sense. So let's see, if his animals together have a total of 95 heads, let's take that fact. We have C chickens and P pigs. The total number of heads that those animals have together is, well, every chicken has 1 head and every pig has 1 head. I think we can assume, although it doesn't actually say that. But so the total number of heads they have is C plus P. And okay, now how about the total number of legs that they have? Well, these are regular old chickens. They probably each have 2 legs. So the number of legs that C chickens have is 2 times C. And the pigs hopefully have 4 legs each. So if you do 4 times the number of pigs, that will get the number of legs that those P pigs have. So that should add up to 310 legs total. So these are the equations we can use. I want to solve this with elimination. Let's say I want to cancel out the 2C here. So I can do that by multiplying both sides of this by -2. That's going to leave you with this new equation, -2C. Distribute the -2 in there, gives you -2P equals -190. And then if you add these together, -2C plus 2C is 0C. Then we'll have 2P equals 120. When you do 310 minus 190, you can divide both sides by 2. Should give you P equals 60. So that sounds like the number of pigs should be 60. If you plug this P in for one of these other equations, the first one looks a little easier. That'll give you C plus 60 equals 95. And if you just subtract that 60 from both sides, you'll see that C is equal to 35. So it sounds like there's 35 chickens and 60 pigs. All right, now let's look at exercise 4, the last one here. We've got the graphs of these 2 equations. Let's write the equations and verify that the coordinates of the intersection satisfy both equations. So it looks like the intersection should be -2, -3, x equals -2, y equals -3. Those should be values of x and y that you can plug into each of these equations that make them true. So what I would do here is get the slopes of each of these two equations. So with this first one here, let's see, what is the change in y when you go from y equals -3 up to 3, that's an increase of 6. And the change in x is going from -2 up to x equals 0 here. That should be 2. So for this one, the slope, the change in y divided by the change in x, should be equal to, let's see, 6 over 2 is 3. So the equation of this one should be y equals, let's do b plus mx. The intercept is b, that should be 3 here. And the slope is also 3. So if you get them mixed up in this case, it's all right. So that should be that first one. And then let's look at the other one here next. So from here, let's look at the change in y down to this point and the change in x. So the change in y is going to be, we're going from y equals -3 down to y equals -5. So that's a decrease of -2. And then the change in x is going from -2 -2 up to 0. So the change in x is 2, just like it was with the other one. So for this one, the change in y over the change in x is -2 over 2, which is a slope of -1. So this one, if we write it as y equals mx plus b, the y is -5 is the y-intercept. The slope is -1. So you can write that as -5 minus 1x, or just -5 minus x, of course. And so that should be our two equations. We now need to verify that the coordinates of the intersection satisfies both equations. So let's try that. Let's take the first equation here. We're going to do y, which is -3. Does that equal 3 plus 3 times -2? Let's see. That gives you -3 equals 3 minus 6. That works. Okay, so yeah, that means that -2, -3 is a point on this one. Sounds good. And then with this one, we're going to do the same thing. We're going to say -3, is that equal to -5 minus -2? So it's going to give you -3 equals -5 plus 2, which is true. So yeah, so that means that one works. And this one works too. So I'm putting a box around the answers because I know they're good. And that is the end of section 2.6. I'll see you on Canvas. We are going to be doing some kinds of online office hours. I recommend that you work on stuff during that time so you can always ask me questions and ask other students questions. And I'll see you then. Just keep washing your hands and not touching your face. Take care.